and welcome to LeetCode with me. Um, we are streaming live daily LeetCode problems and solutions. Today, I'm going to be talking about a LeetCode hard problem called Basic Calculator. It's not really such a basic problem, it's a hard problem, and it involves basically evaluating an expression from that it can include pluses, minuses, and parentheses. And so our expressions can actually get quite complex, and basically we want to write a program to interpret this and then return the result. And we're also not allowed to use any built-in functions that perform this functionality for us because that would be defeating the point. So anyway, let's dive in. Let's just go ahead and sort of rephrase the problem statement so that we're sure that we understand it. So first we have a string s, and it represents an expression. And we want a basic calculator to evaluate the expression. And we want to return an integer result. Okay, so this is pretty straightforward. We have a couple of examples here, so we can look through these examples and determine sort of what we need to do. So we can see that in example one, we have one, and then we have some white space, and then we have a plus, and then we have some white space, and then we have a one. So the white space can just be safely ignored, but we do need to take this one, which is our first operand, and this one, which is our second operand, and evaluate them based on the sign that's in the middle, which is plus. So as we can see, this would be 1 plus 1, and that would result into 2. So we can see that we're going to be iterating through the string, and we are going to be processing these items in the order that they appear. However, it gets a little bit more complicated once we factor in some order of operation stuff and also add in parentheses. So in this example, we want to go here and we have 2, and then we have minus, and then we have 1. And so what we want to do is we actually want to subtract 1 from 2. And so we need to essentially track the sign of we want to apply a particular sign to whatever the next number is. And the same thing is true if we had like -2 plus 1, we need to be able to handle that situation as well. So as soon as we encounter this, we know that whatever comes subsequently in this expression is going to be negative. Well, whatever the immediate next operand is going to be, we want to invert the sign for that particular operand. We could even potentially have a minus and then a sequence of an expression within parentheses, and then we also have to consider that we have to invert the sign for the numbers within those parentheses. So then this evaluates to 3. 2 minus 1 is 1, plus 2 is 3. So these two are pretty straightforward. Now we get into the real meat of the problem, which is example 3. And so for this one, we have s is equal to this expression. And as we process this expression, we have certain things that we need to evaluate with priority relative to the others. So these we can just kind of evaluate left to right, and it's all good because addition and subtraction have the same priority in our PEMDAS then as each other. And then, however, but for parentheses happen first and they have priority. And so we need to evaluate these parens before we do that. And so whenever we're seeing sort of conditions that need to be evaluated first or later, we're thinking about a stack. So we can see that we start with sort of like the outermost layer of the stack, and then we have a stack depth of 1. This is also the stack depth of 1, but then within this, we also have a stack depth of 2. So what this means is that we want to evaluate this expression first at the stack depth 2, get the entire result of this, And then, and only then, can we actually completely evaluate this expression. So the result would be 4 plus 5 plus 2 is 11. And then we can evaluate this one, which is going to be 1 plus 11 minus 3, which is 12 minus 3 is 9, plus, and then we evaluate this one separately. So this one would be, so this section evaluates to 9. And then this section here evaluates to 14. So 9 plus 14 is in fact 23. So this is how we get this result here. So let's go over to the implementation. So we've determined that we need a stack for this. So we have our stack. And then we also have our operand. This is going to be important as we evaluate the string from left to right. We have a sign, which starts as a positive. So this is going to be +1 or -1, depending on our sign character. As we only need to worry about addition and subtraction in this, we can worry just about a sign. We don't have to worry about other operations that might apply in different variations of this problem. And then we also want to do something to track the ongoing result of the result of the ongoing operation that we have here. So these are our four key variables that we're going to be using. And then we want to iterate through the string. And if the string if the character is just like an empty character, we can just continue. Otherwise, we want to check if it's a digit. And if it's a digit, we can just add it to our operand. So we can do operand is equal to operand times 10 plus, and then we want to convert our integer to a digit. So we can either do this by, this is the easiest way, is just doing that integer conversion for that particular digit. And then we're done with processing digits. So we're going through here and then we're adding it. And then every time we find a digit, we're adding it to our operand. There's a couple, we should go through all the cases for what C could be. I'm just going to write stub this out for now so that we make sure that we cover all the cases. And then elif C is equal to open paren pass, elif C is equal to close paren. Okay, so what do we do in any of these cases? So the first case that we want to do is we want to handle addition. So if we've read here, we have one operand to the left, and then what we want to do is we need to figure out how to evaluate it and add it to our result. So because we're only dealing with addition and subtraction, we can actually just consider this left operand that we've already processed and just add that to our the result of our evaluation. We're just passing kind of linearly through the evaluation, and so we can progressively evaluate that and just add that to the result. So the first thing that we can do is just add our operand to our result, but we also need to consider the sign. We start with a positive sign. As we're reading this one, we say, okay, we have a 1. So then that becomes our first operand. We skip the white space, then we get to this plus, and we say, okay, well, we can evaluate everything to the left of this, so we'll just add this to our result. We have 1, and then we don't need to worry about this anymore. So the next thing we can do is we can just set our sign to 1 because we have a positive number here. And then we want to reset our operand to 0 because we've already considered it and we've added it to our result. Oh, that makes sense. So then what we can do now is we want to consider the minus case. So what we can do is the same thing, operand times sign. So we're just we're just dealing with this last operand, regardless if it was positive or negative. And then we invert our sign to negative, and then we reset our operand. Great. Sorry, operand is equal to 0. So great. Now we have an expression that actually handles all of our different cases. And so the last thing that I want to do is the only thing it doesn't handle now is open and closing parens. So we have open and closed parens. These cases are not handled, but we do handle all of our addition and subtraction. So we should be in a pretty good spot to be able to evaluate an expression like this. Let's actually walk through it. So we start with a positive sign. Then we read in this operand. So our operand is now 2. And then we apply the subtraction. So we go here to our elif, c is equal to subtraction. So we add operand times sign to our result. So we add 2 to our result. So our result is 2, our sign is -1, and our operand is 0. So once we get to this operand, we add this to our operand. So our operand is now 1. Um, the next character that we hit is this plus. So our result is now 2, our operand is 1, and our sign is -1. And now we've hit this next plus, so our operand is 1, our sign is minus, and then we add that to our plus. And so that makes our result equal to 1. So we've successfully evaluated this entire expression as 1. Now, because this is positive, we're changing our sign back to 1, and then our operand becomes 0. We read in 2 as the last value for our operand, and then, after skipping the white space, and then we reach the end of the array. But the problem is that we still have one operand that we haven't evaluated yet. We need to add that to our result before we actually return it. So we're going to do return res plus sign times operand. So we're just doing this one last time for our last number in this for our last operand in this sequence because we've reached the end. So we just need to evaluate whatever the last expression was. So that works really well, and we should have example 1 and example 2 passing now, and it does. And also example 3 passes, but we haven't implemented this yet. So let's dig into that. The reason why this passes is because there's no precedence here for anything that needs precedence. The test case that wouldn't pass is if we did something like this. So we have our expression here, which is a string. If we had minus there, the whole point, when we put a minus here, we want this whole expression to be evaluated, and then we want to invert it. So that would be a key thing that would differentiate success from failure in this case. So let's see, these 3 pass, and then this one fails because we haven't done this. Because we're just adding the parens here, we're not doing that inversion, and so the order of operations doesn't actually matter at all. So that's an interesting thing to note. So how do we actually do this? Well, once we go into this parentheses, we actually enter an entirely new state as we're processing this. So we're going into into a new layer, and we're beginning an entirely new evaluation of everything that's in the parentheses from scratch. But what we need to do is we're only partially of the way through the evaluation of the outermost segment. And so what we need to do is essentially just work exactly like the same way that recursion does with the call stack. And we need to save the process of our in-process evaluation so that we can come back to it later once we're done with this evaluation. And we'll do that using the stack. So all we need to do to save that on the stack is that we can just append it to the stack. So we'll do stack append, and we have 2 key pieces of information that we need to save on the stack, and that is our current result and the sign. And this is important because we have reached a new operand. Remember, every time we reach a sign, we we evaluate whatever the previous operand is. So we know already when we reach this point, the operand is 0 because the last possible thing that we could have encountered here is either a plus or a minus. And so we've set the sign accordingly, and we've reset the operand to 0. So we don't need to store the operand here, just whatever the current result is, as well as the sign that we're currently working with, so that we can handle cases like this. So that saves the state of the evaluation in the stack as the last element in the stack. And then what we want to do is just reset the sign to 1, just like we did here at the top. And then the last thing that we want to do is we want to reset the result to 0 because we're doing an entirely fresh operation. Now, as I mentioned, the operand is already 0 because the last thing that we did was set it to 0 because it had to be either plus or minus. If you want to be extra careful, we could actually set the operand here back to 0 in case of requirements change, but it's not necessary, so I'm going to leave it out. So this is actually all we need to do to handle open parens. The next thing that we need to do is handle our closed parens. So what we're going to do is we're actually going to evaluate the last result. So the same thing as we did here when we finished this entire operation. We've reached the end of this, so we need to evaluate the last operand, whichever the operand is plus the sign. So we'll do res plus equals operand times sign. This should feel pretty familiar at this point. Then the next thing that we need to do is we want to retrieve the state, retrieve the state that from our previous operation and sort of restore it, and then also apply our uh, the previous state and the state that basically we're finished with this evaluation, and then we need to combine the result of this evaluation with the state that we were in the previous evaluation. So if this evaluates to 9, and then 9 plus 2 is 11, so we've got the result here. We've computed it. Then we need to basically restore whatever state was in our previous stack frame, if you will, and then apply the calculated result, which is 11. And so the way that we do that is that we can actually just restore that. So we'll get the last value and the last sign. We'll just pop that from the stack. So this is where we were in our last evaluation. And then what we want to do is we want to just add it to our result. So we do result. So first thing we want to do is our last sign indicates whether or not this was a positive or a negative evaluation for this particular expression, a sub-expression here. And so we need to do res times equals last sign, which is this minus here in this example. And then, of course, we do res plus equals last value. So this result being the result of the current evaluation. So we have this is the result of the current evaluation. This evaluated to 11. And then we have stored the last value, which was positive 1. So we say we have 11 so we have 11 as the result. We make that negative 11 by multiplying by the last sign, which is here. So we have negative 11, and then we add the last value, which is 1. So this is negative 10. And so that is the result of that operation. And then as we have applied this operand to the result, we need to make sure that we are resetting that operand to 0. And so all in all, these are all of the steps that are necessary in order to restore the state once we evaluate one of these sub expressions. I'm going to run it. Great. So that works. Boom, and it passes. So yeah, we're using a stack. We're iterating left through right through the string. We're handling all of these different cases, addition, subtraction, open parens, and close parens. We're using a stack to retain the state as we go into one of these sub expressions within the parens. And then we're popping from the stack in order to restore the state and evaluate the expression, and then apply that state to the parent expression. And then this allows us to get a successful result with plus and minus and open paren and close paren. And that we can call this one correct. Yay! Solved. Amazing. So this is a solution for 224 basic calculator. I'm LeetCode with me. I'm happy you guys joined me for this sort of solution review here. I stream every day, FAANG, Leet, LeetCode interview prep and system design. I hope to see you join me for my stream or watch some of my videos on YouTube. I'm working on covering more solutions for difficult problems and talking about general interview prep stuff. And so there's also a Discord channel that we basically help each other get through the interview process and prep for interviews. So if that's something that interests you, then follow along. Oh, and one thing I forgot to cover here was the time and space complexity. So for this problem, our time complexity is O of n because we are iterating through the string once. And then, yeah, so we're doing exactly one iteration through the string, and then our space complexity. It's possible that, I guess, in a edge case where everything is invalid, maybe we'd have n over 2 open parens if it's a valid expression. But we can just say that this is O of n as well because we'd be using one stack frame for every open paren. It would actually be n over 2 or something like that, but this is a pretty good approximation of upper bound. So that's the last piece. And yeah, please feel free to join me as I stream live daily or watch more of my YouTube videos. I'll be doing a follow-up session for Basic Calculator 2 in the next video. So I hope you will join along for that. Thanks for watching.